good that I hear now that it works. I wasn't sure.
We tend to be quiet until we get a critical mass. So it is the top of the hour, but I'm going to wait a few more minutes to see if somebody else shows up. So it's not just Karsten, Marco, and Martin, as we often have.
Hi, quick audio test.
We hear you.
You sound great.
Thank you.
Okay, we have Ricard joined and Ira. So I think that's enough critical mass. It's 1 minute past. Let's go ahead and start. Welcome to the CBOR bi-weekly call. And well, let's just get started right into the agenda. The main thing we need to finish today, after we get through the rest of the agenda, is the Prague session agenda. So let's make sure we leave time for that. Karsten, hit it.
Okay, I don't have very many slides. I want to talk about two documents. One is in ISG processing and one is approaching working last call. So let's talk about the document in ISG processing right now. So this left the working group on August 23rd as -09, and we got an AD review and submitted -10 based on that. And Francesca initiated an IETF last call, which will end on the weekend. And we have a telechat date on the 26th, so one week and a day from now. Right now, the directorate reviews are coming in. We got a very, very juicy review from Art from Thomas Fossati, and that led to a pull request that is already merged. And we recently got an IoT review that also generated a pull request that hasn't been reviewed yet. So we have a little bit of time to do this. And the SecDir, GenArt, and OpsDir reviews are pending. So it makes sense to occasionally look into that repository or watch it if you know how to do this on GitHub, and see what other pull requests are coming in there. But right now, these are really all editorial clarifications, which are really useful. So it's nice that these reviews are coming in. So the telechat next week, we may want to roll up all these pull requests into a -11 before the telechat, or we may want to do this after the telechat. Let's see how the remaining reviews and the ISG comments look like, but this is just moving forward. And the CDate document this is depending on is on the telechat tomorrow. So I hope we can get that done in time so it doesn't slow us down. Any questions on time take? Then let me move on to EDN. So I always have this slide that reminds people that EDN is something different from CDDL. It's a bit too easy to forget that. So we're talking about diagnostic notation right now. And as you remember, we started with a draft that discussed application-oriented literals. And that draft has grown into something that could be called EDN maintenance and extensions. So extended diagnostic notation, maintenance and extensions. Maybe we want to change the title at some point. Anyway, for 2 weeks ago, we had the plan to quickly do address the issues number 11 and number 12. One was missing text about encoding indicators, and the other one was a missing IANA consideration section. And we thought this would lead to a -05, and we would do a working blast call right away from that. Now, this is not what happened. There was tons of useful feedback, and so we went ahead and filled in a few more gaps that are between what is deployed out there and what was documented, and also filled in a few feature gaps. So based on that, we submitted -05 yesterday, and now can do a working blast call again, probably at the same time as working blast calling update 8610 grammar. So I put those changes on one slide. So first of all, Christian had the idea that we maybe want to have a way to preserve application-oriented literals when an EDN ingester doesn't understand the application-oriented literal. Of course, the resulting CBOR data item is a bit bogus, but yeah, it probably should be an option for an EDN ingester to actually accept unknown application-oriented literals, but we now have a defined representation to hand them around at the data model level. So this is kind of trivial. An application a tag with an application-oriented literal contains the literal and the text, and we put this into an array and tag that with 9 and 9. The second thing we noticed is that we never got around to actually documenting the ellipsis feature that we discussed in an interim about a year ago. So we wrote some text and some ABNF for that. This was tag 888. And the idea is that in a specification, you can write something like a byte string that starts with 4711 and ends with 0815. And here on array that has an initial member with a mail address and another member that is not further specified in this example. And people who are writing examples will be very happy that this gets added, because it allows tools to actually know which parts have been elided, and so the tools can just stop checking them because they were supplied for exposition only, or they were not supplied for exposition only. The third one is we had forgotten to document appendix G.4 of 8610. So this is chunked strings. You can write sequences of string literals, and they get automatically combined into one, and we just hadn't written that up. And finally, we noticed that we have this RFC there, 9164, that really cries for having an application-oriented literal. So we decided to just put it in, because I mean, we have the RFC 2.2, so it wasn't that much additional work. So the application-oriented literal addresses IP addresses as well as prefixes, but not IP addresses with net masks, because that's we don't have well accepted notation for that we could put into an application-oriented literal. So everybody understands this /24 thing that is on the slide, but combining an interface address with its net mask is not something where we have a single standard way to do this. While we were doing this, we noticed that the prefix notation actually only works very well when we identify which kind of address we have. Normally we can see what kind of address we have because an IPv4 address is 4 bytes and an IPv6 address is 16 bytes. But prefixes have their redundant 0 bytes removed, so you cannot see whether this /24 is actually an IPv6 address or an IPv4 address. It would be a weird IPv6 address, but we shouldn't disambiguate this on semantic considerations. So we needed a way to actually say, put in the tag. And that way turned out to be just writing the application-oriented literal in uppercase. And we not only added this to IP, but also to DT. So you can now have a datetime tag, actually, in the form of an application-oriented literal. So that was the last change. And the whole thing is now -05. And I think this could be working with last called if we want.
Okay, I think at least this chair would go ahead and start a working group last call. Probably we should wait till after IETF 118, just so we don't overload people who are getting ready to go to the meeting.
Well, last week the plan was to start then, so I wouldn't be opposing any last call that we start now.
Okay, that works for me. Then
so
we just extend it to a week after, have it end the week after IETF 118.
Or we could end it so we actually have the result by the meeting and can put lids on things.
Okay. Yeah, sure. Let's do that. Okay.
I think this has been around in interims often enough that those interested have a good starting point.
That's true. You're right. Okay. So we'll start it today and end it, let's say the Monday of IETF week.
Yeah, sounds good. So we can talk about it at the hackathon.
Okay.
Okay, that was all I had.
Oh, that's okay. So then we move on to the grammar update, the 8610 grammar update, for which there's no slides. Who's doing that?
Yeah, I just wanted to mention that 2 weeks ago we said this was ready for working with last call. So it's still ready for working with last call. And we just wanted to have it at the same time so people look at the ABNF at the same time.
Yes. Okay. So we're doing both of them. Okay. Good. So the next thing on there is Martine, it looks like.
Okay, then slides.
CBOR and DNS. So let me get back to the slides. There we go.
Okay. So yeah, I guess most of you know already what I'm working on. So, and I will only present some evaluation on the name compression that we talked last interim about. But yeah, first I get the motivation still, and then summarize the ideas we talked about last time, and then I'll go into the evaluation. Yeah, first we have these two graphs that I showed last time. They are CDFs of the compression ratio and byte savings. Basically everything left of the red dotted line is larger than the wire format, and everything right is smaller than the the wire format. So yeah, we have some that are very good and some that are not so good, and especially this long tail here on the byte savings side was something that we noticed last time, which was because there are some responses that have a lot of names in them, which can be compressed and are compressed in the DNS wire format. So the question was, do we need name compression for the base format? And basically, I interpreted the last discussion as, yes, we need some name compression. And so I put forward two ideas. First of all, do it like the DNS wire format, so reference name components within the CBOR object, or do a packed CBOR Lite where you have a predefined table of names or name components and reference them like we do in packed CBOR. So the reference name components is basically loosely based on Christian's idea to componify the name. So basically, instead of having a text string in being the domain name, we have components. And I basically extended this idea to add references. In this case, I added some tags to unset integer, in which I called t for now here because I didn't decide on a value yet, but I will come to that later. And this reference tag basically references a name component. And the question was, how would we do that? What would the unset integer actually be? In the wire format, this is basically the offset of the name within the message. So in CBOR, the equivalent would be the offset within the CBOR object, but this turns out to be really complicated to implement because lists can grow during the construction, so the pointer always changes during construction. And so I decided for much easier approach to basically just take the is t string when you have a tag ti. And there was also a question, how do you recognize that the name ends? Well, because I now use a dedicated tag, it's basically just scan for the name as long as this object is a t string, or the tag t, it's a name. And so if it's not in the comp definition of the CDDL, then you basically left the name and you can stop scanning for the name. And you can see now how this referencing would then work here on the left side. And in my evaluation, I basically used two tag values. First 7, so 1 plus 0 byte tag, and 48, so 1 plus 1 byte tag. The reason is because in DNS, these pointers are in the DNS wire format. These pointers are always 2 bytes long. So I wanted to see if this makes sense to keep these 2 bytes, or if the 3 bytes that we get with a 1 plus 1 byte, assuming that these numbers within the tag are always very small, are worth anything. So any questions up until here first before I go into the next idea? Okay. Oh, Carsten. Yeah.
Just takes me a long time to actually find those buttons. There is a tag 25 that was defined right in 2013 or 2014, I forget, which is called string referencing. So essentially the tag gets replaced by the nth previously seen string.
I missed that.
So
that's good to know.
Yeah, so your counting goes forward while the counting of tag 25 goes backward.
And there's also slightly different semantic to just taking the previously seen string, but yeah.
I haven't checked the detailed semantics here, but I just wanted to put this in as a data point. So we have had this functionality for a while, and maybe it's worth looking at the small differences here. So does it even make a difference going forward or backward, or is it just easier?
I think it's easier with going forward, because I will show this on the next slide. But also, as I said, the semantics are a little bit different, because you don't just take the is string, but you also take everything that comes after it and belongs to the name. So, for example, this ns1 here in my example would be ns1 example.org. So the semantics are a little bit different than just taking the next the string.
So you essentially take the rest of the array.
Yeah, not the rest of the array, but the rest of the array until it's not part of the name anymore. So
okay.
Yeah. Because, for example, for this ns1 example, I wouldn't take the r type, which is 12 here, and the one which is a class. I wouldn't take those, of course. And if the name was the name of the record, not the R data here in this example, I wouldn't, of course, not take the TTL into account and stuff like that. So it's a little bit different, and I admit a little bit hard sometimes to wrap your head around it at first, but I will come to that.
Yeah. Okay, so that was my first observation. I think that would just be useful material for a paper about this, to point to this older thing. And the other question is, what do we, I mean, how do we actually save something here? So one thing, of course, is the implicit table building. So we have an algorithm to build a table that uses the occurrence of a text string and actually adds things that, in the same array that also contribute to a name. So that's the implicit, what I will call implicit table building. And that, of course, saves having to actually express the table explicitly as an array. And it saves the reference from the first occurrence to the table.
I actually, you will see this later when I show the CBOR Lite format, where this the object that I show here is marginally bigger, and also in the evaluation you will see this. So you're getting ahead a little bit.
Yeah, okay. I'm just trying to I mean, you can measure this. That's really useful to do, but then you can try to understand what's going on. And I think the point about explicit tables is that you have some overhead for setting them up, but then the overhead of actually using them can be very, very small.
You mean implicit tables?
Explicit tables.
Okay, explicit tables.
Yeah, so let's see how that works out.
Yeah. So as I mentioned before, another advantage of this format, to jump ahead a little bit, is that it's, at least in Python and also in C now, I also did it in C, it's really easy to implement, because you basically just have to count the names as you add them to your object. And if you have a prefix that matches this name, you basically just, not a prefix, a suffix, sorry. A suffix, then you basically just append the tag. Yeah, it's that's the nice thing about this. While with CBOR with CBOR Pact, if you, at least if you want to do it correctly and assume that there are more than 16 values in there, you might need to also count the occurrences of the string. So how often a string appears, so that you can prefer the more often appearing ones and adding them first to your explicit array. So the other idea, as I said, was this packed light idea, which is basically a somewhat extension of this proposal by Arnaud Lemoque and collaborators. They used a dictionary to reference the name. We basically just use an array. And we basically use the same semantics that we have with CBOR packed here. So basically, we now have NS1 also here in referenced in the table by the tag, and in the rest of the array, we actually use simple. But of course, we could also use the inverted rump reference within the object itself. So yeah, basically for at least the CBOR folks, this probably looks like the more straightforward solution. Or are there any questions on that?
If this is done as basically the regular packed CBOR setup, would the whole thing be tagged? I mean, it's one or probably 2 bytes overhead that are not shown in the diagnostic notation, so it would be like tag 113 of yada.
I couldn't follow that, but
so if this is this is precisely the tag setup as described in packed, the packed setup as described in packed as tag 113.
Then you have an implicit.
The tag 113 is implicit here. Or?
Yeah, it is. It is. Yeah, sorry.
Okay.
I skipped that completely because I forgot about it because I didn't use it in DNS in the DNS format by now. So yeah. But yes, it would be basically like tag 113. Okay. Then I did the evaluation. I used the same data corpus I used for the other evaluation before. I just did a little bit more experiments. First of all, I, of course, repeated the experiments from last time, or basically used the same results. And then also did the component referencing, which I called compref in these experiments results, and did it, as I said, with tag 7 and tag 48. And for tag 7, I also did a packed variant where I used only references when string as a shared value and not allowed for inverted references like the draft proposes, because since we are now using only name components, it doesn't make sense to assume that there are suffixes within these name components. If there are, they probably are quite random. And for packed light, I looked at the unpacked format as packed light, and the packed format, I basically just used the same that we have already defined in the draft. And again, I looked at the compression ratio and the byte savings, which I defined here. So the compression ratio is the relative measurement, and the byte savings are the absolute measurement. And yeah, first let's have a short look at the old results again. But for easier reference, I also added the plots that are relevant also to the other plots. Because when we look at the queries, we don't win as much with the component references, but that's not that much of a surprise because we only have a small advantage when, for example, DNS SD queries are there where you have additional records or authoritative records, and that is this small bump that we see there in the compression ratio and these smaller, even smaller steps that give an advantage to the savings. If we look, however, at the responses, we see, of course, much better results where we have the compression reference, the component referencing in orange and purple here, and in magenta we have the packed light. And we see here that the packed light format, at least for the smaller savings and compression ratios first, is very much identical to the packed format, while the component reference format is actually a little bit better for the smaller compression ratios and byte savings. And of course, also not that much surprising, we have a very small advantage on the component referencing when we use 1+0 tags. But overall, we can say that we have only very little responses that are not compressible anymore. We have this very small tail, at least with the component referencing. With PEG Lite, there is this small bump into this dividing line. Okay. For when the same as when we can omit a question within the response, there we see a similar result. And for smaller compression ratios, as I said, the component referencing is a little bit better, and pretty surprisingly for the 1+0 tag. Because, as Carsten already pointed out, PEG Lite introduces a small overhead by the extra list and the additional reference that you have in there. Then for the PEG-CBOR variant with the component referencing, we see this very small advantage of when we use shared value references, and also no surprise because we basically assume with inverted referencing that there are similarities in the suffixes of the name components, which is not a given. And so we basically introduce some overhead for some random similarities. And this actually is shown in the data. So to conclude this is basically that if we use name compression, we have nearly no compression ratios that are smaller than 1.0. So everything, most of the data we looked at is compressed. And the difference between the component referencing and PEG Lite is marginal. I personally have a preference for component referencing because it's more concise, because we don't have this extra overhead. It is simpler to implement, as I pointed out earlier. And another bonus is that, at least for DNS implementers, it might be more familiar because it works exactly as the classic DNS name compression works. And just to give this addendum about the flags, last time I talked also about the flag rotation, maybe to rotate the flag in the options, because we could save at least 2 bytes with that. But given that we already have over 1.0 compression ratio without this modification, I think since the advantage is negligible and we only win those 2 bytes in most cases, I would say it isn't worth confusing implementers with having to rotate the bytes. Okay, are there any further questions? Christian.
I'm sorry if this has come up earlier and I missed that. You mentioned the compression of responses without requests. Wouldn't it make sense, no matter whether the request is repeated in response or not, to tap into the requests dictionary, tables, already initially? So I mean, I don't know.
I mean, that's basically what happens if you include the question, then it uses this question as a dictionary in both compression formats.
Yeah, but it still repeats them once, right? So if I'm sending my request and that contains my very long name .example.com.
Well, it depends a little bit. If the question isn't present because since we use DNS over CoAP or DNS over HTTPS, and we already can associate our question from what we have in our state, that's basically how you are able to omit the question.
Okay, so
if you don't have the question, you need to get the names from somewhere else, which is most often then from the answer or from something somewhere else, if they are provided even. I mean, you can completely omit the names in general, anyways, if you can get them from the context.
Okay, so so there are ways of sending a response that doesn't include the long name.
Yes.
Okay, so there is no need to set. So if the DNS resolver is set up to make the responses small, then there is no need for cross-referencing into the table set up for the request.
Yes.
Okay.
So, but that's only true for responses. But with queries, of course, you always have to send the name because you need the name.
Yeah, but the responses, but there is no. Okay, yeah.
Yeah. Any further questions or comments? Yes, Carsten?
Yeah. So if two people have a difference in opinion on some issue, it's rarely the case that one of the two people can't think clearly, but usually it's a difference in perspective that brings you to a different opinion. And I think this is an interesting case of that. So the I think you call it name compression. I'm still not quite sure about the terms. So the implicit as you go approach is slightly more efficient than the explicit tables approach that CBOR-PACT uses. So if this was all we need to look at, and I think that's pretty much your perspective, of course, as a researcher who tries to look at the various approaches and find the best one, then we clearly would decide for that. On the other hand, CBOR-PACT is a generic component that can be used in many places. So the same constraint device that needs to use DNS is probably going to use other sources of data and can also benefit from using CBOR-PACT there. So from an ecosystem point of view, how do we make the CBOR ecosystem more powerful by including some packing there? It probably would be there probably would also be a preference for using the same format that is being used for other data. So I think it's really important to understand what is the impact of choosing one or the other. So right now you have to compare to the old DNS format, and you call it wire format. All these formats are wire formats. But maybe it would be interesting to have these tables or graphs to look at directly comparing the two packing approaches, so we can see how important it is to have something specialized for DNS versus having something that can be used for other data as well.
Yeah, I agree. I can look into that and probably present it in Prague.
Yeah, and the other thing that I think would be interesting to look at is would it even be possible to do something like implicit table setup with CBOR-PACT? So can we actually eat the cake and have it too? I haven't thought much about that, but I'd like to think about this a little bit. And so reaching ahead a little bit in the agenda of this meeting, we need to talk about the agenda for 118. And I like that right now both CBOR-PACT and the DNS representation are on the agenda, so we can discuss this together. I think that's a good thing, and it's a good thing that we have a couple of weeks and a hackathon to actually work on this before we have this discussion.
Yeah. So I'm already pretty spread thin for the hackathon time, I have to admit. But yeah, we'll find a way.
Right.
I think I'm not the only one.
Yeah.
Okay, if there are no further questions in common, I guess we can't find a final decision yet, but yeah, I guess I will still do a version 5 of the draft where we'll do some other stuff that we discussed previously, and some stuff I noticed during implementation. So we'll have a version 5 on Monday, but not including this yet. Do you all agree with that? I guess yes, right? Okay, then thank you from my side, and yeah, see you in Prague.
See you in Prague. So that takes us to the Prague agenda. Well, we clearly have, as we've said, CBOR Pact and the DNS on the agenda. What else do we need on the agenda other than the normal updates where we are with the documents?
Yeah, if we have working class calls that actually
Right.
finish by the meeting, then it would be obvious to discuss the working class call results then.
Right. So it's the documents that are in progress, and then these two, right?
Right.
Is there anything else we need besides all that? Or is that an easy agenda?
I've lost a bit of track on the various variations of DCBOR. Is there anything summarizing to say there, or is there any progress to report?
Well, we haven't done much work on that in the last couple of weeks, but of course we want to pick this up again. I'm just not sure that we will make a lot of progress in the next couple of weeks.
Well,
so maybe that's more for an interim to pick up again.
Sure, but having at least a few minutes on it in 118 will get people level set and remind them that we are moving on it. So why don't we put it on the agenda just for a few minute, maybe a 5-minute thing. What do you think?
Yeah, it's never going to stay 5 minutes, but yeah, I think we just need to make sure that we don't use the term DCBOR as the heading, but really a deterministic encoding profiles and things like that.
Okay. And okay, so then the other thing that will also go on the agenda and that we can talk about now is the proposed dates for, so we're moving on to the proposed dates item on the agenda. Proposed dates, which we coordinated with Core. Thank you, Marco, as always. He always reaches out to me before I reach out to him. So it's, but these, the dates that are here represent the same cadence that we had in the same weeks of the year. And I just presume we're going to continue with that every 2 weeks, canceling when we don't have anything to say. The question we have is, do we do 6 March, which is, it's still a week and a half before the IETF meeting, so we could do it. But I'm suggesting that we not schedule that one and use 21st of February as the last interim before IETF 119. Does anybody think we really need the one that's a week and a half before the meeting?
Well, I think it's typically useful to have a slot after the internet draft deadline.
Okay.
So I would just schedule it, and we can always cancel it.
Sure. All right. I'll put that up on here. So then that's going to be 6 March. And let's get rid of that. Okay. So we're set with that, and that will go on the agenda for discussion at 1:18, and then will be checked out on the mailing list. I have nothing else. Does anybody have any other business?
Thank you.
Okay. Thanks, everybody. Thanks for coming. And we'll see you in Prague.
Thank you. Bye-bye.
You're in
Thanks.
Prague.
Thank you.
Bye-bye.
Bye.
Bye.